Yes, in this video, let us discuss about dielectric materials. After we have discussed the two types of materials, that is conductors and semiconductors. So this is the third category of materials, that is dielectric materials. So what are these dielectric materials? The dielectric materials are basically non-conducting materials which have the property to undergo polarization. So what is this? Let us see. You see that initially we have neutral atoms or molecules in the material. When we apply the electric field to that material, these neutral atoms or molecules turn into dipoles. Now we know that dipole means an entity where you have equal and opposite charges separated by a very small distance. These kind of dipoles get formed in the material when an electric field is applied, and such materials are called as the dielectric materials. Now this dipole has a value called as dipole moment, which we denote it by symbol mu. It is given by the product of the one of the charge q and the distance of separation between the charges, that is L. So that is the dipole moment. Now the process of formation of dipoles, that is the separation of the concentration of positive charges and the concentration of the negative charges in a material by the application of the electric field, that is called as the polarization. Now polarization as a quantity, we can write it by this equation. Polarization P is equal to epsilon naught into epsilon r minus 1 into applied field E. Here epsilon naught is permittivity of free space or vacuum. Epsilon r is relative permittivity, or also called as the dielectric constant. Now this dielectric constant we know is given by this relation. It is the ratio of the capacitance of a capacitor with the dielectric divided by the capacitance of the same capacitor without the dielectric. So that is what dielectric constant epsilon r is. Now let us see some two types of the dielectric materials. One is polar dielectric. So what is a polar dielectric? So in polar dielectric we see that each molecule is polarized and is having permanent dipole moment. The molecule, by intrinsically it is having polarization and it is having a dipole moment. That's why we call it as permanent dipole moment. Now example for this is water and ammonia. Now the dipoles we see, they are formed in the material, but we see that the orientation of the dipole is random in nature, because of which the net polarization of the whole block of material becomes zero. So polar dielectrics can get the net polarization or net dipole moment only when a applied field is there. Otherwise, in the absence of the applied field, the net polarization becomes zero. Now let us see the next type of material, that is non-polar dielectric. So in this non-polar dielectric we find that the atom or molecule, every atom or molecule is unpolarized, that is it is neutral. So the atom or molecule can become polarized only in the presence of the applied field. So only when we apply the external field, the atom or molecule can become polarized. So that is what a non-polar dielectric is. Example is nitrogen, helium, oxygen, like this. Now let us see the different polarization mechanisms that happen in a given dielectric material in the presence of the applied field. So therefore the total polarization, the net polarization, is the sum of the four different polarizations that we will discuss now. The first type of polarization is the electronic polarization, which we denote it as PE. So electronic polarization is found in inert gas atoms. So how is the polarization going to happen here? It is by the displacement of the electron cloud in the atom in relation to the nucleus. The nucleus will be shifted to one end and the electron cloud will be shifted to the other end, opposite end. So that way each atom will become polarized, and that is the basic type of polarization that will happen in a material, that is called as the electronic polarization. The second type of polarization is ionic polarization, denoted by Pi. It is found mainly in the ionic compound, example like sodium chloride, potassium chloride, like this. So how is the polarization happens in this material? The polarization happens when the positive and negative ions in the ionic compound are displaced by the application of the external field. The third type of polarization is the orientation polarization, denoted by Po. This is found in the polar dielectrics, like water. So how is the polarization happens here? We see that in polar dielectrics there are already existing permanent dipoles. Only thing is they are randomly oriented. When the electric field is applied, these randomly oriented permanent dipoles will orient or rotate and align in the direction of the applied field. So that way the whole material will get polarized. So that is called as the orientation polarization. The fourth type is the space charge polarization. It's a weakest type of polarization that happens in a material. It is found basically in materials which are having different phases with different conductivity. So in a same material there will be different regions with different values of conductivity. And when the electric field is applied, you find that the charge carriers store in regions of higher conductivity, that way leading to the polarization in the material. So here its example is it's found in ferrite and some of the semiconductors. So these are the four type of polarizations that is found in a given material. So therefore the net polarization can be the sum of the electronic polarization, ionic polarization, orientation polarization and space charge polarization.